Okay, welcome back. This is part two of the first section 6.5 of week 2. So now we're just going to go in reverse here. So we have base 6, which again, it doesn't matter what the base is. What we're focusing on is the fact that this is a product of two terms, 3 and x, and we call this expanding. They're saying rewrite each log expression, but we call this expanding. Spell. And all I'm going to do is rewrite it as two separate logs. So log base 6 of 3 plus log base 6 of x. Again, product again, expand. Natural log of 5 plus natural log of y. Now notice this division. So we subtract. And again, the big thing the big mistake students make sometimes is they write this as log of 7 over z, but that's not what the rule is saying. We actually write it as two separate logarithms. So this would be log 7 minus log z. Okay, and it's not just 7 minus z either. Again, over here, the base is not as important right now. What is important is we are dividing, which means I can write this as log 2 of a minus log 2 of 6. Now this is a couple things going on. Hopefully you notice that it's multiplication here and multiplication here. So you could write this out a few different ways. There's I mean, the order is important, but you can rewrite this in a variety of ways to get your point across, okay? So log base 5, you could say one way of doing this is of 2x minus log base 5 of 3y. Okay, 3 times y. Now, if we do it this way, which is, again, is totally fine, we want to put some invisible parentheses here because you will be distributing. So now this becomes log base 5 of 2 plus log base 5 of x minus log base 5 of 3 minus log base 5 of y. So this is, again, one way of doing this. And again, if you combine it, you can check your work by condensing it. The plus signs here tell us it's going to be 2 times 5. The minus signs here means that you're going to divide by 3 and then divide by y. Okay. Over here, same idea. So try this one on your own. Pause it, try it, and then come back. So log base 7 of x plus log base 7 of 3 minus x minus, run out of room here. Okay, so log base 7 of x plus log base 7 of 3 minus x minus log base 7 of 5 minus log base 7 of y. So you may come up with your own kind of generalization, like, oh, if it's in the denominator, it's going to be minus. Yeah, that's good. Yeah, that's right. Exactly right. Okay, over here, again, this is the property we're going to probably use a lot more than the other ones when we're solving. Is all they're saying is if you have an exponent, you just can move it right to the front. So this becomes 5 log base 4 of x. This becomes 3x log 2. This becomes parentheses x minus 1 log base 8 of 3. Now this goes in reverse. You can rewrite it as log base 2 of a to the 5th. Okay, you can rewrite this whole thing, bring it up in front here. Log base 7 of 9 to the 5b, and over here, this is in parentheses, so natural log of 3 raised to the x minus 5 power. All right, and now this one is, again, a pretty useful property. So if you have this is a base, and this is a base. If these base matches, then there's basically saying you're left with the input, which is just 7. Base, base, x. Base, base, a to the third. Now this is the change of base formula. You need to use this if you're going to evaluate and you don't have one of the newer calculators. So for example, some of you guys who have those new calculators, you could look at this problem, you could say, oh, well that's just, like you'll get a prompt. It'll get like a blank box here and a blank box here. And you can fill in the boxes with 5 and 16, right? And that's only the newer calculators, the TI-84s. Not all of them have that. So if you don't have that, then you have to use a change of base formula. And what we're going to do is use a common base. What's kind of cool about this is it doesn't matter what base you use. So you could either use LOG, which is base 10, or LN, which is base E. And you could test it for fun. I'm sure you guys got a lot of free time. So for fun, test all these, and you'll see you get the exact same answer. So log base 5 of 16, this time I feel like a natural log. So I'm going to go natural log of 16 over natural log of 5. And this you can evaluate in your calculator. This time I feel like a common log. So we'll go log, which is base 10 of 5, over log, which is base 10 of 3. And this time I'm feeling natural. So I'll go natural log. Natural log of 3 over natural log of 7. All right, so these are the different ways of using the change of base formula. And now with this, you could evaluate any log that you're not as familiar with. Okay. All right, so we are, I kind of like stopping at pages. So this is page 2. So we'll stop here, and then we'll continue after this.